Hi guys, your Friendtor Gopika is here, and today I will start with the chapter 3, that is circle in Maths 2. Okay, so this video is for recall part. That means we will recall all the things that you have learned in your previous chapters or in previous standards and how we will use it in the concept of circle. We will also learn few new things regarding the number of circles passing through a single point, through 2 points and through 3 points. Okay, so in 3 points you have two cases, that is collinear points and non-collinear points. So we'll perform activities to understand all these things better. Okay students, so without wasting time, let's get started with the recall part. Okay, so let's recall few things that you have learned in the previous standards. Okay, so you're familiar with the concepts regarding circle like center, radius, diameter, chord, interior of the circle, exterior of a circle, all that. We also know what are congruent circles. Okay, two circles are congruent, then the radius are of equal length. Okay, so if you have two circles with same radius length of the radius is same or equal, then those two circles are congruent circles. All right, concentric circle means circles with common center. So from, if you choose this one single point and we draw many circles, 1 2 3 4, okay, a number of circles you can draw with this point as the center, then all those circles will be called as concentric circles since they have a common center. Next, intersecting circles, that means if two circles are overlapping at some portion or some portion of them are common, then they are intersecting circles. All right, next. Okay, so in these activities, so there are 2 to 3 activities in which we will revise the theorems or properties that you learned in 10th as well as in 9th. Okay, in 10th means you just learned it one chapter before in the second chapter, and in 9th means you learned this few theorems regarding chord and perpendicular in your 9th, where you had a chapter on circle and you learned 2-3 theorems regarding equidistant chords and chord and perpendicular, all that. Okay, so we will revise those things using this activity. Now in the adjoining figure, segment DE is the chord of a circle. So here DE is the chord with center C. Segment CF is perpendicular to segment DE. If the diameter of the circle is 20 centimeters and DE is 16 centimeters, find length of the perpendicular, that is find CF. Okay, now we will recall the theorems and properties that we will use to find the solution. Okay, so the first thing is they have given the hint, the perpendicular drawn from the center to a chord. Whenever you have a chord DE and from the center if you draw perpendicular, then that perpendicular bisects the chord. Okay, that means F is the midpoint of DE. CF bisects DE and F is the midpoint of DE. That means DF is equal to FE is equal to DE upon 2. So if length of DE is given, then length of DF and FE is half of it. So here DE is 16 centimeters, that means DF and FE is 8 centimeters. So first theorem that we are using is the perpendicular drawn from the center to a chord bisects the chord. Okay, this theorem you learnt in your standard 9th. If you don't remember, please go back, take your textbook and find the theorem. This is the first theorem that you learned in the chapter circle in your 9th standard, that is in your geometry max 2. Okay, next what we will use here is very common property, that is radius is diameter upon 2. This you are learning from 8th or 7th. Since you are learning circle, you know radius, the relation between radius and the diameter. Next, third, Pythagoras theorem. We just learned in the same year, that is in 10th itself, in the previous chapter Pythagoras theorem was learned. So here how we will apply the Pythagoras theorem. So we will make a construction, or you can make a construction, can join CE, okay, or you can join CD. If you are joining CE, you will get a right angle triangle CFE with FE's length you know, CE's length you know, since CE is the radius of the circle and diameter is 20 means radius is 10 centimeters. So CE is 10 centimeters, FE is 8 centimeters, and hence you can find CF using Pythagoras theorem. And Pythagoras theorem says hypotenuse square, that is CE square, is equal to CF square plus FE square. Okay, so I gave you the hint or the theorems or properties that we are going to use or that you can use. Solution you can find. It's very simple, just 2-3 steps you will find the answer. Just applying Pythagoras theorem to this triangle. Or if you join CD, again you will get CD to be the radius and CFD will be the right angle triangle. DF is 16 centimeters, CF is 10 centimeters, hence you can find CD. CF is not 10 centimeters, CD is 10 centimeters and DF is 8 centimeters, so hence you can find CF. Okay, so in either way you find, make any of the construction, you will get same value, and that's it. Okay, yeah, so let's see the next thing. Okay, here I can tell you the values also. Okay, 1 second. So CF is what we need to find. FE is 8 centimeters, CE is 10 centimeters. So CE square is equal to 8 square plus CF square. That means 10 square is equal to 64. 100 is equal to 64 plus CF square. Okay, so CF square is 100 minus 64, that is 36. So CF is square root of 36 and CF you will get it as 6 centimeters. Okay, so solution also I told you. So just write those 4 steps. Actually here the aim of the activity is to recall the that you have learned before. So the perpendicular drawn from the center to a chord bisects the chord is that property. Okay, next, activity 2. Here we will use the converse of the theorem that we stated in the previous activity regarding the perpendicular and the chord. So in the adjoining figure, segment QR is the chord of the circle with center O. So here O is the center, QR is the chord, P is the midpoint of the chord QR. Okay, so the theorem says that if you join radius to the midpoint of a chord, then that segment is perpendicular to the chord. That means OP is perpendicular to QR, since OP is the line joining center and midpoint of the chord. Okay, so in previous activity the statement was, if you draw perpendicular from the center towards the chord, then it bisects the chord. Here it is converse. If you join radius to the midpoint of a chord, then that segment is perpendicular to the chord. Okay, so here if QR is 24, OP is 10, find radius of the circle. So same construction, join OQ or OR, both are radius. So that is the that is the length which we need to find. QR is 24, that means QP is 12 and PR is also 12. OP is 10. So here OQ square is equal to OP square plus PQ square, Pythagoras theorem, or OR square is equal to OP square plus PR square, again by Pythagoras theorem. Why? Since OP is perpendicular to QR. So the first theorem that you're using is segment drawn from center of the circle to the midpoint of the chord is perpendicular to the chord. Okay. Next, Pythagoras theorem on QPR. Okay, not QPR. Oh, sorry, I made a mistake over here. It is OPR. Okay. On triangle OPR. On this triangle or this triangle, you can apply Pythagoras theorem and directly find the answer. So OQ square is equal to OP square plus QP square, and 10, QP is 12, 10 square plus 12 square will be, 10 square is 100, 12 square is 144, you add it, you get 344, and then hence find OQ square. Okay, square root of 344. Next, this is the third activity. Here we are going to revise the theorem regarding equidistant chords. Okay, two chords which are equidistant from the center are equal in length, and two chords which are of equal length are equidistant from the center. These two theorems also you learned in standard 9th. So in the adjoining figure, here all we want is just recalling the statement of the theorems. Okay, so proof actually it got over. What you require in future or what you will use in other applications or in proofs of the other theorems will be the statement of the theorems that you learned previously. So statements are important. So in the adjoining figure, M is the center of the circle and segment AB is the diameter. So here M is the center, AB is the diameter. Segment MS is perpendicular to AD. Similarly, segment MT is perpendicular to AC. Then angle DAB is equal to angle CAB. So here they have made the markings that these two angles are congruent. Okay. Prove that chord AD is congruent to chord AC. Okay. So here what all things we know: MS is perpendicular to AD, MT is perpendicular to AC, and these two angles are of equal length. We need to prove that chord AD is equal to chord AC. So here we will use the fact that two chords equidistant from the center are equal in length. Okay. So to prove that they are equidistant from the center, so the distance from the center will be given by the perpendicular. So MS is equal to MT. If I prove, that means chord AD and chord AC are at equal distance from the center. That means they are equal. So we will need to prove that MT is equal to MS. To solve this problem, which of the following theorems will you use? So first we will use the chords which are equidistant from the center are equal in length. Next we will use one of these tests and prove that these two small triangles AMS and AMT are congruent, and hence if they are congruent then MS is equal to MT, since they are corresponding sides of congruent triangles. Okay, so let's check how to prove that those two triangles are congruent. Here we go. So consider triangle AMS and triangle AMT. Here angle ASM is equal to angle ATM. Both are 90-degree angles. Next, angle SAM is congruent to angle TAM. Why? It is given in the question. Okay, SAM is different name for DAB and TAM is a different name for CAB itself. The angles are same. So SAM is equal to TAM given. Next, there is a common side to both the triangles, that is AM. So segment AM or side AM is congruent to side AM, since they are common to both the triangles, that is common side. So by AAS test, we can say that the two triangles, triangle AMS is congruent to triangle AMT. Okay, that means MS is congruent to segment MT, since they are corresponding sides of congruent triangles. Therefore, the chord AD and AC are equidistant from the center M, hence they are congruent. So chord AD is congruent to chord AC. Okay. Okay. So the next topic is circles passing through 1 point, 2 points and 3 points. Okay, so we are going to discuss, if you have a point on any plane, a single point, then how many circles will pass through it? If you have 2 points, then how many will pass through both the points? If you have 3 points, then how many circles will pass through all 3 points? Okay, all those things we will learn or we will discuss. So when you have one point A, n number of circles pass through it. Okay, then you can make infinitely many circles which will pass through this A. So this is like, if you choose a point and draw, you can like keep on drawing many circles. Okay, many will be intersecting to each other, and you can make n number or infinite number of circles passing through a single point. Okay, so in the adjoining figure, point A lies in a plane. All the 3 circles with centers PQ are passed through the point A. We can draw many more circles passing through A. Okay, so passing through A we can draw many circles. Infinite number of circles pass through a single point. When you choose one point, infinite number of circles pass through it. Let's see what happens if you choose 2 points. Okay, so here you have A, B, C, 3 points, and if I say we need to find the number of circles that will pass through A and B. Okay, just 2 points if we pick, how many circles will pass through them? To understand that, let's see the activity. Okay, so this first activity is regarding to discuss how much circles will pass through 2 points. Then we will discuss regarding 3 points, collinear and non-collinear points. Okay, so here draw segment AB, draw perpendicular bisector L of the segment AB. Okay, so you have 2 points AB, so join and form a segment AB. Now draw perpendicular bisector of the segment AB. Take point P on the line L as center. PA is radius. Okay, now this will be the center. So if you take a compass, keep center on the P, then keep the pencil point on A and try to draw a circle. You will see that the circle passes through A as well as B. Okay. Now take any other point Q on the perpendicular bisector. Take QA as the radius and draw a circle. Again the circle will pass through B. Now choose any point R below. Take QA or QB, RA or RB as the radius. Draw a circle. You will see that that circle also will pass through A as well as B. So why this happens? This is by a very simple property or observation about perpendicular bisector. It says that every point on a perpendicular bisector, you take any point on the perpendicular bisector, it is at equal distance from A and B. Okay. So all the points or every point on a perpendicular bisector is equidistant from the endpoints of the segment. And that's why you choose any point, take from that point, take the A as the radius, that is QP, QA or QB as the radius, and then draw a circle. Then that circle will pass through A also and B also. Okay. So now here there are, on this line, on a line there are infinitely many points. So if there are infinitely many points, we can construct infinitely many circles such that it passes through A also and B also. So when you have 2 points, there are infinite number of circles which pass through those. Okay. So the conclusion is there are infinite number of points on line L. Therefore, infinite number of circles can be constructed passing through both the points A as well as B. Okay. So next, let's see the activity regarding 3 points. So this is activity 2. In this, take any 3 non-collinear points. Okay, non-collinear means they are not lying on the same line. All 3 points does not lie on the same line. Now, draw a circle passing through these points. Now, how to draw a circle passing through all 3 points? This can be easily done. What we need to do is we will find circumcenter. Okay, in 9th standard you learned a construction where you can find circumcenter, or you can construct a circle which pass through all the vertices of a circle. Okay, you learned 2 constructions in 9th. One was incircle and another was circumcircle. Incircle means a circle which is inscribed, which is inside the, which lies perfectly inside the triangle, and circumcircle means a circle which fits the triangle, or a triangle is lying within the circle perfectly. Okay, it is passing, a circle which passes through all the vertices of the triangle is a circumcircle. So how to draw a circumcircle? Now first what we need is, we have a 3 non-collinear points, so we can join them and form a triangle. To find the circumcenter of, we will draw perpendicular bisectors of the all 3 sides, or any 2 sides you draw, and find the intersection point of the perpendicular bisectors, and that point will be the circumcenter. Okay, so from that point, keep the compass on the, keep the center on the intersection point on the circumcenter, keep the pencil point on the any of the vertex of the triangle, and draw a circle, and surely it will pass through all 3 vertices of the triangle. Hence we can construct a circle which pass through all 3 points of all 3 non-collinears. Okay. Now the question is it possible to draw one more circle passing through these 3 points? The answer is no. Okay. So for any triangle there is a unique circumcenter. Okay. Unique circumcenter means there is a unique point of intersection of perpendicular bisectors. So if the circumcenter is unique, then the circle drawn is also unique. So we cannot draw any other circle which will pass through all these 3 points. Okay. So there is a unique circle passing through 3 non-collinear points. Now let's see what happens if the 3 points are collinear, if they lie on the same line. Okay, that is activity 3. Take 3 collinear points D, E, F. Try to draw a circle passing through these points. So if you take D, E, F, now it's impossible to draw a circle such that it passes through D also and E also and F also. Okay, if I draw a circle like this, all 3 points pass through, it means it is impossible since it is lying on a same line, okay, on a straight line. So one possibility is if I cover DE, then F will be outside. If I cover FE, D will be outside the circle. If I cover passing through D and F, then E will be inside. E won't lie on the circle. So one of the points will lie either exterior or interior to the circle, but it won't lie on the circle. So when you have three collinear points, we cannot draw a circle passing through all these points. Okay. So a line can intersect the circle maximum at 2 points. So these 3 points, if I join and make a line, then that line will cut the circle only at 2 points maximum. Okay. So if you have 3 collinear points, a circle will never pass through all of them. Okay. Yes. Now that's all with the activities and the revision on points part. Next we will learn definition of tangent and secant, and we will learn the tangent segment theorem also. But that I will cover in the next video. Okay. Okay. So that's all for today's video. Please like the video and share it with your friends. Please subscribe the Friendtor channel, and you can also follow us on Instagram. And if you have any doubts regarding any lectures that we you see in this channel, or you have any doubts regarding mathematics, then please write in the comment section, or also you can DM us on Instagram. We will respond as soon as possible. So thank you.